All right, it's recording. Exercise 5AB. We're now on to exponentials and logarithms, but we start off with exponentials as usual. Because you've already learnt transformations, you can now read what these letters represent. Let's go. Let's test you guys now. D is the easiest one. What's D do to this exponential graph with base B? Can I please have Alex? What does D do? Up or down? Very good. What does A do? Can I please have Albert?
It's dilation.
Dilation of what?
The x-axis.
Or factor. I mean, factor.
Factor the x-axis.
Well, it's factor A, whatever this number is, from, and you're correct, it is the x-axis. Okay, because you're affecting the y value, so it's away from the x-axis. And what is this n? Let's go with Noah.
N, that's from the y-axis, but I think you have to flip it over, right? So it's 1 on n.
Very good. Dilation of factor. In this case is 1 on n from the y-axis. Very good. And then finally you got your C, which represents what? Let's go with Ella. Good. Translation. What we're missing in there is any reflection because there's no negatives at the moment, but it means that N and A could also have a reflection. Oh, I gave you space there. Sorry, my bad. I should have just wrote it here. So it could be a dilation or reflection. So dilation from X and reflection in Y. B is just the base. N is your dilation from Y, but reflection in X. C is to move left or right, so you can say translation. Horizontal. And this is also translation, but vertical. And part of exercise 5A is literally doing what we just did there, is that your ability to read a graph, move it up, down, left, right, including its properties. Now let's go to properties. What are some properties that we know for exponential functions? Can I please have, let's go with Rango. What's the domain for an exponential function?
It's always like above D, and it doesn't include D in that form.
Oh, you're thinking?
Domain, sorry, I'm thinking range.
Yeah, you're thinking range.
Domain is just all values.
All real values, good. So X is an element of R, all real values. And then the range, Rango gave a hint already. Xavier? What's the range?
D.
Very good. So D to infinity, and in this case, make sure it can't include D, because clearly there is an asymptote. Where can I please have, who would I have chosen? Serena. Well, how do you write it though? What's the equation of the asymptote? Very good. Oops, I did something there. Let's do backwards. Y equals D. So equation of your horizontal asymptote. So I'll just write horizontal in case you didn't know. That's a horizontal asymptote. And then your y-axis intercept. What do we know? Usually the y-axis intercept is at 1 because when the power is, if x is 0, usually it's 1, but it depends on if there's any translations. Okay, so I'm going to write here usually. So that means when you're sketching, these are things that you've got to look out for. Asymptotes must be labeled, the equation of asymptote must be labeled, and your y or x intercepts must be labeled. Yes? Yes. I just put a plus. See, so it could be minus or it could be plus, depending on how you want to read it. But usually, yeah, minus so that you know that you're moving to the right. It's very good. That's why they in your turning point form, they usually write x minus h squared plus k. When I teach it, I just don't like students memorizing that it always has to be minus h. That's why I do just x plus b plus c, just to make it feel like you have to know how to read it instead. Yeah. But you're correct if you wanted to move it to the right. just to make it all look nice and easy. All right, next one. Let's go sketching now. Let's try to do this. Let's read the transformation, shall we? Let's start with Samuel. Dilation. Give me a dilation. Not factor 5 and not 1 on 5. I know what you're thinking. It has to be in front of the x. So the 5 is not in front of the x. If it was in front of the x, you would have been correct. It would have been 1 on 5 from the y. But because it's separate, it is not a dilation factor there. Someone else? Albert? Where's a dilation factor?
Oh, where's the dollar? What's that?
Which is 3. Good. Dilation factor 3. So this is a dilation. It's anything that's multiplying. So dilation factor 3, in this case, it's affecting the y value, so it's from x. Give me a reflection in this case. Let's go with Tara. Very good. So that 1 in front of the x, anything that's multiplying to the x, okay? So right now I've got a negative 1 times the x. That's why there's no dilation factor, except it's a factor of 1. But there is a negative, so hence it is a reflection in the y-axis because you're affecting the x values, okay? Next one, translation. Give me a translation that you can see. Let's go with Adrian. What's a translation you can see? 5 in? It's in the positive direction. Did you say positive first? Maybe, but it's positive. So it's actually 5 in the positive direction first. Well, actually, it's a reflection. Well, it depends on how you want to see it, but yeah, it's depends on how you say it, actually. So this one here, you could look at it as negative x plus 5, so hence you know it's moving to the right. But if you took out the negative as a common factor, you could do that, but you didn't have to. So I would say it's to the right by 5. What else is there? Right by 5 and? 1 up. Very good. So up 1. Okay, so let's state the asymptotes then. So that means if you can picture the graph, it goes to the right by 5, up by 1, and there is a reflection. So you can picture it now. But let's look at the asymptote. Let's go with Ian. Where's the asymptote? It is at 1 because we've gone up by 1, so y equals 1 is your asymptote. You should have a horizontal line. Make sure to rule it. Don't do what I just did. Make sure to dot a line, but it has to be ruled. It has to be a nice linear line. Y equals 1. We know that it is reflected. So I know that the x-intercept, the y-intercept has to be below 1 somewhere. Okay? I don't know where it is. It could be down here. It could be there. But we know that the y-intercept must be less than 1 because it's reflected. Right? So normally it's like this, but it's reflected. So we need to find the y-intercept. What is the y-intercept? Can I please have Ryan? Is it 0, is it? Y-intercept is when you let x equal to 0. So in the equation, if you let x equal to 0, is it? 2 to the 5 times 3. 2 to the 5 is what? That's 32, is it? Yeah, 32. So, yes, 96 plus 1 is 97. Wait, something's wrong then. Oh, sorry, because it was a reflection of the y-axis, wasn't it? Not the x-axis. I drew it down this way before. There's a reflection in the y-axis, so it should have looked this way. That's why it's always good to check your y-intercept. See what I did? So checking your y-intercept, we know it's up here, 0, 97, and drawing the graph. When you draw it, make sure it's one continuous curve, and make sure to not curve the ending tail. Okay, so don't draw the examiners normally look just towards the end. They actually look at that tail end. If they see a little curve up, they'll take a mark off. Okay, so you can't have something that even shows that it points up, not even a little lump and it comes back down. It actually has to be coming towards. So they'll look just towards the end. Okay, so just make sure that towards the end it's approaching a certain value. Okay? There you go. So usually your 3 marks is on shape, axis intercept, and any key features. Key features, your asymptotes. Okay, so you should have shape. So draw it correctly. Axis intercepts. And then key features. Key features in this case would be asymptote.
Reflection in X is N, but then on the thing, when N was negative, you wrote reflection in Y.
Oh, that's wrong. This is to do with the X value, so it is reflection in the Y axis. My bad. My bad. Sorry, thanks for picking that up. I don't know if you guys picked up on my error there. That should have been, A should have been reflection in the X, because it's flipping the Y values. And then reflection in the Y because you're flipping the X values. So N should have been Y and reflection in X. My bad. All right. That's pretty much what we just did. There's exercise 5A and pretty much 5B as well. Let's do another couple examples so you get a feel of it. Flip over to the next page. Well, this one's pretty much similar. I'll get you to sketch it instead. All right. Let's see. Let's give you, I reckon it should take you about 2 minutes. Let's go. 2:33, 2 minutes. And it's recording again. All right. Here we go. It's good to see that everyone used that +2 as your asymptote. So you should all have a nice horizontal line that runs across, and it should say y equals 2. So that's one key feature. That's one mark. Second mark to note, that negative, that's a reflection in your x-axis, so it means you flip it vertically. So you're going to flip the graph. So normally the graph exponentials will go up like this, but because it reflects on the x-axis, you expect it to be something like this. What I don't know is where my x-intercept and y-intercepts are. So you're going to find your x and y-intercepts first. Let's go. Y-intercept is when x is equal to 0. Let's find y. So f of 0 is equal to 2 minus e to the power of 0 minus 1. And you get 2 minus e to the negative 1. And 2 minus 1 on e is perfectly fine. The logic to that is e is about 2 point something. So it's like saying half. So 2 minus half is still a positive value. So you know y-intercept must still be positive. So 0, 2 minus 1 on e. That's perfectly fine. Let's find the x-intercept. X-intercept is when y is equal to 0. So 0 is equal to 2 minus e to the power of x minus 1. Here we go. Minus 2 on both sides. Again, negative 2 is equal to negative e to the power of x minus 1. Shh. Thanks, team. Try not to speak while I'm speaking. It's disrespectful. 2 is equal to e to the power of x minus 1. And then from here, you have to use logarithms. Remove the base e. Opposite of base e is log base e. So if you took log base e on both sides, log base e on both sides, we know that log base e and e cancels out. That's why you end up with log e of 2 is equal to x minus 1. Now, some of you might have learnt it this way. Some of you might have learnt just doing the conversion. So you would just convert that first step into log e of 2 is x minus 1. But essentially, I'm just doing balance the equation. Okay? So whatever you do to one side, you do to the other is what I'm doing there. So I did here, that was minus 2. Then over here, I said times negative 1 times negative 1. And all I did here was log base e of e to the power of x minus 1 and log base e of 2. Okay? All right, and then what's your final answer? X is equal to log base e of 2 plus 1 because I add 1 on both sides. And x equals to log e of 2 plus 1. You don't need to know what that is because we already know the graph has to look something like this. So log e of 2 plus 1 has to be more positive. Okay, so I don't know where that is. I'm just going to label it here and write log base e of 2 plus 1. And that is sketching. X-intercept, Y-intercept. Okay? Hands up if you got at least, so remember 3 marks. 1 is for the first key feature, so asymptote is 1 mark. Shape, which knowing that it is a reflection in the x-axis, that's 2 marks. And the third mark is having axis intercepts. Hands up if you got all 3. All right, well done. Very good. Okay, that's 5A, 5B. If you had time to have a look at the next one, the biggest giveaway was the asymptotes. You can try to read reflection and moving to the right or moving to the left, but the asymptotes were the biggest giveaways. Tyler? Yes, that's the same thing, yeah. So ln or log e, yeah, means the same thing. No, means the same thing. All right, so here, if you did it correctly, asymptote at -1, so -1's this one, so this must be A. This one has an asymptote at 3, so this must be B. And then the last one in green has an asymptote at -2, which was a giveaway, C. Obviously in the exams, they try not to give you too many of the asymptotes that's easy to see. And then you have to look at the left, right, up, down. But asymptotes are a good way to figure it out. So far, so good? All right. Flip over to the last page. We're on to exercise 5C now.